going to solve this example with the absolute value inequality by first isolating the absolute value piece. That should always be a first step in any absolute value equation or inequality problem. Here at this point, I get the following absolute value inequality. Now, if you click on view the example or go to the textbook, it's going to give you a couple of different rules that you can use to help you solve this inequality at this point. And if you're fine with those and understand those well, that's okay. But I want to show you one other method that you can use to kind of help you with these inequalities, especially because sometimes the rules get a little overwhelming. I want you to think back to what absolute value really does. It kind of masks what the sign of its argument is. Like, I don't know if 1 minus 3x is positive, 0, or negative, because I know that what's going to come out of the absolute value will always be positive or 0. So I'm really going to write here two statements. I'm going to say, okay, there's going to be this statement where this stuff inside this absolute value, this argument is going to be positive. And then I'm going to write another statement where it's negative. And I need to solve both of these inequalities separately. I solve this first inequality. This next one I can divide both sides by -1 first. I know that's going to switch the sense of the inequality or its direction, and then solve from there. And I forgot to mention this at the beginning, but because the original absolute value inequality was less than, I know that these two solutions are going to be joined with the word and. So it's an intersection of both pieces. So sorry about that technology snafu there, but anyway, what I'm going to do to get the second part of this answer then is graph both of these inequalities and look for their intersection, since I'm combining them with the word and that's why I would then choose this particular graph.